All right, so here we're asked to find the limit as x approaches 2 from the left of this rational expression. Now the first thing I'm going to do is factor the denominator here. I notice that does factor. And so I'll just go ahead and do that real quick. And what do we have there? A 2, so we have 2 times 1 adds up to -3 if they're both negative. And then a negative times negative is positive. Looks good. Okay, now if I do the direct substitution, I can see here that I'll have a 2 plus a 5. Remember here, x is going to 2. That's not -2. That means x is going 2 from the left. So we're actually substituting 2, right? 2 minus 2, and then 2 minus 1, right? So that gives us 7 over 0 times 1, which is 7 over 0. Okay, so 7 over 0, some sort of infinity. All right, so that's going to be either positive infinity or negative infinity. So we need to figure this out. Notice here nothing cancels, so the only thing really we can do is sort of analyze maybe the graph, and we can see here that at 2 we are going to get a vertical asymptote. So let's do a sign chart around 2. Now, knowing that I do have a vertical asymptote at 2, I can actually just analyze the sign on either side of that critical value there. Okay, so if I take a 3, or say 2.5 or something like that, I'm just going to do this mentally. Plugging in 2.5, I'll have a 7.5 on the top, a 0.5 there, and a 0.5 there. All of those factors are going to be positive. So on this side of the 2, on the right side, we're going to get positive results. Now if I substitute, say, 1.5, I could see this factor is going to be negative. So 1.5 will give me a positive in the numerator, a negative in the denominator, and another positive here. So 1.5, testing that value, I can see the result's going to be negative. All right, so if this is a vertical asymptote, my y values are going to tend towards negative infinity on this side of the 2 and positive infinity on that side of the 2. Okay, now we're actually concerned as x goes to 2 from the left. So from the left, we're coming in this way as x values. This is, of course, the x-axis. And so I can see that my results are going to tend towards negative infinity down this way. All right. So after analyzing the graph or the sign chart here, or you can even substitute in values and use a table of values here, I could see this result, the limit, is going to be negative infinity. Okay, so here I went to desmos.com and I typed in the expression that we were taking the limit of, and this is what I got. So do notice that we do have an asymptote there at 2. We also have another asymptote over here at 1. But we're only concerned about what's happening to the y values when x approaches 2 from the left. So let me get a little more space here. You could see here's my asymptote. So as I come in from the right, you could see that the y values are tending to positive infinity. But as I come in from the left, I need to scroll down. My scale's off a little bit here, but you can see once I scroll down far enough, the y values are tending to negative infinity. So that does match with the analysis that we did. So let's go over to Wolfram Alpha next and see if that can actually make the calculation. Okay, here we are at wolframalpha.com, and I'll type in the limit as x approaches, so that's the dash in the triangle bracket, 2, and then I'll put a minus. That means 2 from the left. And then in parentheses, the numerator here was x plus 5, and the denominator was x squared minus 3x plus 2. Okay, so that's how you would type it in. Hit the equal sign. And we could see here the limit, as we can see, we typed it in right. The limit as x approaches 2 from the left of this rational expression is negative infinity. So we verified our result on Wolfram Alpha. It also shows the limit as x approaches 2 from the right, which we saw from the graph was positive infinity. And then it gives a little picture similar to Desmos here. And we got it. Okay, so great.